guys, hello again. So in this video we are going to discuss ground effect. Alright, so there are basically three things that you have to know. What is ground effect, what happens when you enter ground effect, and what happens when you leave the ground effect. Alright, so first I'm going to explain on the first page is what is ground effect, what exactly is ground effect, why does it happen. Alright, so in the last video, if you remember, we discussed trailing edge vortices and wingtip vortices, right? So when a plane is landing or taking off, alright, something like this. Okay, so if you remember, it was anti-clockwise on the right wing and clockwise on the left wing. Now what happens is when landing and takeoff, the closeness of the wing towards the ground, like this is the ground, alright, so the closeness of the wing towards the ground, it avoids the full development of the trailing edge vortices basically, and this makes the trailing edge vortices weaker. Okay, so we'll just write down trailing edge vortices become weaker. Since it is too close to the ground, it does not complete the whole thing. Trailing edge vortices become weaker, and this indirectly makes the upwash and downwash decrease, they reduce, and that increases the effective angle of attack, okay, of the wing. And when the aircraft is in ground effect, lift is generally increased and induced drag is reduced. Okay, so this is ground effect. This phenomena is called ground effect. When the trailing edge vortices become weaker, the lift is increased and this induced drag is reduced due to the increase in the effective angle of attack is called ground effect. Now what is effective angle of attack? Alright, so we have to discuss that. And in addition, the reduced downwash will affect both the longitudinal stability because of the CP movement and the pitching moment because of the changes of effective angle of attack of the tail plane. Alright, so in the stability chapter we'll discuss this, and I'll explain what is effective angle of attack. Alright, so we know what is angle of attack, right? The simple angle of attack. But say this is the aircraft, okay, so this is your main wing and then you have your tail plane. Okay, so relative airflow, we know that is the airflow hitting the aerofoil, but the tail plane does not get relative airflow. Why? Because it has been affected by the aircraft itself. So this is called effective airflow, and the angle between the chord line and effective airflow is called as effective angle of attack. So basically I'll write down 3-4 sentences so that it's clear. Airflow which has been influenced, like I said, influenced by the presence of the aircraft is called effective airflow. Okay, and the angle of attack between the chord line and this effective airflow is your effective angle of attack, and it is incident to your tail plane. Alright, so we'll be discussing this in just a moment. So I hope you have understood ground effect. Alright, because of the closeness of the wing, it generally happens all around about half the wingspan. So at a distance less than half the wingspan, the trailing edge vortices become weaker, they are not fully developed, and hence the downwash and the upwash is reduced, and this causes an increase in the effective angle of attack, and hence your lift is increased and your induced drag is decreased. Alright, now we are going to discuss the 2 points that I was talking about: entering ground effect and leaving ground effect. So first we'll do entering ground effect. Okay, so Consider an aircraft entering a ground effect with constant coefficient of lift and indicated airspeed. Alright, as the aircraft descends into ground effect, the following changes take place. Induced drag is reduced, which will cause a reduction in deceleration. Basically, if drag is reduced, your acceleration increases. Alright, and any excess speed that you, because acceleration is increased, excess speed will lead to floating, that floating ballooning feeling that you get. So floating distance is increased. Okay, second point, the reduction in thrust required might also be given. The aircraft's tendency to climb above the desired glide path if reduced throttle setting is not used. So basically what this sentence means is ballooning shall take place. Since the throttles, if you keep the same throttle, the aircraft is already accelerating, floating distance is increasing. If you don't reduce a lower throttle setting, the aircraft will have a tendency to climb because the lift is already increasing because of the reduced induced drag. Alright, so ballooning shall take place. Then you need more elevator back pressure. Alright, so now why is more elevator back pressure required? Elevator back pressure during landing attitude. Now if you remember, we discussed the downwash and upwash shall decrease, right? When you enter ground effect, downwash and upwash will decrease. Alright, so this, what happens is, since you're coming in, the effective, this will lead to increase of effective angle of attack. Okay, so this will lead to a down pitching moment, and hence you need to hold the attitude. Basically it's called the flaring attitude. Alright, so this point I'll write here, the downwash on the tail is reduced, causing a nose down pitching movement. Alright, this point is important because of the downwash is reduced. We are discussing the definition of ground effect. The downwash and the upwash reduce. This causes a nose down pitching movement. Okay, since if your effective angle of attack increases, right, on the tail plane, your nose will tend to come down. So hence the pilot has to apply more elevator back pressure. The last point, ASI and altimeter will under read. Alright, the ASI and the altimeter will under read. This is due to the changes in the flow field around the aircraft will give you a position error, because there's a airflow has changed around the vicinity of the aircraft, so position error is coming. So local pressure at the static port will increase and cause the, so local pressure at static port increases, and hence the ASI and altimeter will underread. Alright, so now we'll discuss the third part rather, leaving ground effect. Okay, first point, same, we'll keep the coefficient of lift constant and IS indicated airspeed also constant. Generally the effect of climbing out of ground effect will be opposite of entering into the ground effect. Alright, so what happens is your lift will decrease and drag will increase. This drag increase means the thrust requirement has gone up in terms of thrust. So the aircraft will require angle of attack higher to maintain same CL. Okay, to maintain same CL, your angle of attack has to be increased. Then second point, both upwash and downwash shall increase. Okay, so now what happens is just the opposite here. Since the upwash and downwash increases when you leave ground effect, the aircraft will have a nose up tendency. Alright, so you'll have nose up tendency due to the decrease in effective angle of attack at the tail plane. Nose up tendency, and this means you have to apply less back pressure on the elevator basically. Alright, less back pressure on the elevator, or you can just leave the pressure on the elevator. And in this case, ASI and altimeter shall overread. Alright, so it is important. The most important point about leaving ground effect is, I'm going to write here, when you get airborne in ground effect at an airspeed and angle of attack which would, after leaving the ground effect, when you are in ground effect at a certain angle and angle of attack and airspeed, you might lift off. But when you leave ground effect, the aircraft can have a tendency to settle back on the runway. Alright, so it is virtually important that you use the correct speeds for takeoff. Example, like the rotation speeds has to be accurate. If you take off, so I'll just write down, if take off at an angle of attack and speed, if you maintain the same angle of attack and speed after leaving ground effect, the aircraft has the tendency to settle down back on the runway. So it is important that you use the correct speeds for rotation, climb out, phase, and etc. Alright, so that's all about ground effect. Now we'll have a small discussion regarding high lift devices. Alright, so high lift devices. High lift devices. Okay, so why is high lift devices are used? Alright, so that is the main objective that we are going to study in the high lift devices. Okay, so the primary objective of high lift devices is to reduce takeoff and landing distances. Right, so basically to reduce takeoff and landing distances, we are going to use high lift devices. Alright, so high lift devices are flaps, your slats and slots, so on. So we'll discuss about types of flaps. First, what is flaps? Alright, a hinge device at the trailing edge or leading edge to increase camber, hence providing you more drag and high lift obviously. So the primary objective of high lift devices is to reduce takeoff and landing distances, that is indirectly reducing your stall speed. Alright, so types of flaps. Okay, so types of flaps. First one is your plain flap. Alright, so plane flap is a simple construction. I'll just draw it so that it's very easy to understand. Alright, so this is your aerofoil, okay, and a simple flap will just come down like this. That's all. From the body it just comes down. Example is your Cessna aircrafts, Cessna 172, 152, etc. They have similar flap formation construction. So it gives a good increase in CL max, but fair bit of drag is increased because it is mainly used on low speed aircraft where the short takeoff is required and not for landing, because landing is anyways speeds are low, so your landing distance is anyways low. So this is a plane flap, just comes out of the wing, it falls down. Alright, second one is your split flap. So split flap, it is like something like this. Draw with the pink. So aerofoil is like this. Alright, so what happens in a split flap is the top surface remains there only, but a surface protrudes out of the lower part of the wing. This is called a split flap. Okay, so the flap forms the part of the lower surface of the wing trailing edge, the upper surface being unaffected when the flap is lowered. It is good for approach and landing, but not for takeoff. Alright, so this is split flap. Next we are going to discuss Fowler flap, which is largely used these days. Fowler flap. So Fowler flap is something like this. So you have a aerofoil, alright, so and then you have like this. So they are Fowler flaps move rearwards. So this is suppose here it moves rearwards, it moves in this direction and then it downwards. So first it gives wing area is increased. Firstly the wing area is increased and then your camber is increased by downwards movement. Camber increased. Alright, because of the downward movement, so it moves rearward first and then downward. This is what we are generally the modern jets use, Fowler flaps. Okay, and it may be slotted because of the combined effect of the slots. The lift of the aircraft increases much higher with the least increase in drag. So you might have a slot. I'll just draw again. So you might have a slot here, some construction like this. So slot helps, I mentioned earlier, slot helps in re-energizing the boundary layer and hence your lift increases. So this is, say, double slotted flap, triple slotted flaps are used. Alright, the last one is your Kruger flaps. Now this is on the trailing edge. Kruger flaps are on the leading edge. This is the key difference between these both. This is a common question asked. Kruger flaps are on the leading edge and the Fowler flaps are on the trailing edge. Okay, now Kruger flap is something like this. This is the leading edge. Suppose this is the leading edge. Alright, so I'll not complete the whole thing. So it's part of the lower surface of the leading edge and can be rotated about the forward edge. So there is a flap system like this, something like this. Alright, so what happens is, this is not deployed yet. What happens when it is deployed? Alright, so it becomes something like, so this thing comes like this, it opens up and it forms like this. Alright, there's a joint here, this joint opens up and forms like this. So this is your, suppose this is your wing and it comes ahead. So now the important features of Kruger flaps is, promote root stall. Okay, and it is used on the inboard section. So I'll just draw the top view so that it's easy to understand. Suppose this is your wing. It is Kruger flaps are used here in the inboard section of the wing. Alright, so this is used to promote root stall on a swept wing. Okay, so that's all about high lift devices. Anything else, please drop a comment. We'll be doing stall in the next video. Alright then, see you guys, bye bye, take care, and don't forget to share it and like it.